In this video, we're going to do a little bit of review on the Pythagorean theorem, and we're also going to look at some new vocabulary and how that applies. So in this one, let's go ahead and give it a title in our notebook. I don't know why I put a 9. Hold on. Let's make this lessons 2 and 3 of the Pythagorean theorem unit. We're just labeling this now. And in the video, if there's anything that I write, you write, okay? So let's recall our formula here. Our Pythagorean theorem is a squared plus b squared equals c squared, and c specifically is called the hypotenuse, right? Now we're going to really try to focus on using that language when we talk about any parts of our triangle and the sides we're trying to find. C, the C side, the diagonal is always called the hypotenuse. Okay, so let's look at an example here. Let's say I have a right triangle, and don't judge my drawing because it is not perfect. Let's say I have this right triangle, or it looks like a right triangle, right? It looks pretty darn close. And I'm going to give it side lengths of 5, 7, and 12, okay? Now, using our theorem, we know that we need to square the sides A and B. So 5 would be like our A, and 7 would be like B. And we don't need to, hold on one second. We don't need to worry about which one's A and B. As long as it's not our diagonal side, it doesn't really matter. So we have 5 squared plus 7 squared equals c squared, which is 12 squared, and c is our hypotenuse, okay? Now we get 25 plus 49, and the question here is, does that, so I'm gonna put a question mark over my equal sign because I don't know, does it equal 144? Well, looking at this, I know just with number sense that 25 and 49 is not gonna be 144. I'm going to keep adding them, go ahead and add them together anyways. I want to see what my total is, and I'm going to get 74. And I know now that does not equal 144. What that means is, since 74, which is the squares of A and B added together, since that is less than the square of the hypotenuse, this is going to be an acute triangle. So we're going to review what that vocabulary means as well. So I'm going to clear this out. If I have a 90-degree angle and I have an angle that is less than, anywhere less than that 90 degrees, that means I have an acute angle. And so if those squares, like we just saw, are added together, it gives us an acute triangle if it's less than a hypotenuse. Same thing goes for if I've got an angle that is greater than my 90-degree angle, that angle is an obtuse angle. So let's see where we might see an example of that in our triangles. So let's say, again, on paper, I might have an example of a triangle that looks like it's a right triangle, but I need to use the mathematics and the Pythagorean theorem to verify that it actually is. So let's recall one more time. Here's our Pythagorean theorem. And so let's give this, let's say this is a 9, 12, and let's say that this one is a 13. Okay. So it might look like, hey, that diagonal is still the longest side, right? Still the biggest side, but let's check it. So we have 9 squared plus 100, just kidding, plus 12 squared. Does that equal 13 squared? Okay, so here we go. 9 squared is 81. 12 squared is 144. And 13 squared is 169. So I'm going to add the left side. We're going to get 225, I believe. Okay. And that is greater than 169. I know it does not equal, so I put a slash there. So really, because 225 is greater than 169, remember, that was our a squared plus b squared. Those squares together are bigger than the hypotenuse squared. That means the triangle is an obtuse triangle. Okay, and then of course, if it does equal it exactly, that means that it's a right triangle. So it's going to be that perfect fit, that perfect match for where our theorem works. So we can use the Pythagorean theorem to verify if three side lengths will form a right triangle. And if it doesn't, what does that tell us? Does that mean it's an acute triangle or an obtuse triangle? So that's this whole section here on using the Pythagorean theorem to see if three sides form the triangle. That is called the converse of the Pythagorean theorem. And again, all that means is that we are just using the theorem, the formula, to see if a right triangle can be formed, and if not, what kind of triangle is formed. Okay?